of class 12. Today we will be starting with the second chapter, that is solutions. So solutions, you already know what is a solution, but here we need to know what is true solution. So true solution is a homogeneous mixture of two or more substances. Okay, two or more substances whose composition can be varied only within a limited certain limits. So let me tell you what is true solution. So true means it has to be homogeneous solution. Homogeneous solution of two or more components or substances, okay, whose composition varies only within a certain limit. This you need to know it. And a solution consisting of two components is known as what? Binary solution. So if it is binary solution, then bi means this bi means what? 2. So this binary solution consists of two components. Okay. So now the solution can be expressed in different terms. The concentration of solution can be expressed in different units or different terms. So we are going to learn about those concentration terms in which the concentration of the solution is expressed. So first one that we are going to discuss about is what? Solubility. So what is solubility? So since we are discussing about solution, so the first thing we need to know what is solubility. So solubility is the number of grams of solids, okay, gram of solids dissolved in 100 gram of solvent. So it is the solids in gram dissolved in 100 gram of solvent. So it is the number of solids in gram dissolved in 100 gram of the solvent. And the number of solids in gram dissolved in 100 gram of the solvent, and it has to make a saturated solution. Please don't forget that, okay? To form a saturated solution at a given temperature. So solubility is what? You have taken 100 gram of the solvent, okay, and in that you are adding some solute particles. Solute particles are like solid particles. Now you are adding that much of this solid particle till it keeps on dissolving, and a point is reached, after which if you add more amount of solid particles, it won't be dissolved. That particular point is known as what? Saturation point. And this reaction has to, this mixing of solid in solvent has to take place at a particular temperature. Why? Because as you know from your common experiences, that if you change the temperature, then the solubility also varies. Now let's come to the terms in which the concentrations are expressed. Number one is the strength. Now we are discussing about the terms in which concentration of solution is expressed. Expression expressing concentration of solution. The first one is what? The strength. So what is strength? Strength, the definition of strength, you need to know it. It is the number of gram of solid which can be dissolved per liter of solid. So it is what? It is number of gram of solids which can be dissolved per liter of the solution. Per liter of the solution. Okay? What? Per liter of the solution. So it is expressed in gram per liter. And if you want to write this in mathematical form, then you have strength will be equal to number of grams of solid divided by volume of solution. This volume has to be taken, volume of solution, and this has to be in liter. Okay, please don't forget. Now, this is one way in which the concentration can be expressed. The other way in which it can be expressed is the normality. Normality of the solution. Okay? And what is normality? Normality is the number of gram equivalent. Please, you have to remember this. Normality is what? It is the number of gram equivalent of solids which can be dissolved per liter of the solution. So it is what? Number of gram equivalent. Number of gram equivalents of solids dissolved per liter of the solution. Okay, per liter of the solution. Now here, this itself can be written in the mathematical form, that is normality will be equal to number of gram equivalent, divided by volume of this solution in liter. Okay, volume of solution in liter. Now there are other ways in which this normality can also be expressed. So these relations, these expressions, you need to learn them, okay? Because you will be asked numericals based on this. Now, the other formula for normality is what? Normality equals to strength of solid in gram liter. Normality equals to strength of this solution in gram per liter divided by gram equivalent weight of solid. So, gram equivalent of solid. So this is the second expression for normality. This was the first one. This is the first expression for normality, and this is the second expression. And you also have a third expression in which normality is related with what? Weight of solid, okay, to the gram molecular, gram equivalent weight of solid. So what normality will be equal to whatever weight you have taken of solid, weight of solid divided by its gram equivalent weight, gram equivalent of weight of solid into, say, this gram equivalent weight. I'll show you how to calculate. Okay, so you need not worry about this. Now this has to be multiplied with 1000 by volume of solution in ml by volume of solution in milliliter. So now let's discuss about gram equivalent weight. Now, gram equivalent weight of an element you can calculate it by knowing its molecular mass. Equivalent weight of an element will be equal to its molecular mass or atomic mass. It's what? Atomic mass divided by its valency. So what is the valency of this particular element? Its atomic mass, you will be knowing it. And if you divide it with valency, then you get what? Gram. You get equivalent weight of that particular element. Now if it is an acid, now for acid, equivalent weight of an acid will be calculated as equivalent weight of an acid will be equal to its molecular mass, will be equal to molecular mass of that particular acid, molecular mass of that particular acid divided by its basicity. Let's take an example. Like if you have sulfuric acid, and if you calculate its molecular mass, then it is 2 plus sulfur is 32 plus oxygen is 16, and it has to multiply with 4. So if you add it up, it becomes 34 plus 64. You get 4 plus 4 is 8, 98. So its molecular mass is what? 98. And what is its basicity? Basicity is the number of replaceable hydrogens, or the number of hydrogen ion it can generate in aqueous solution. So here its basicity is what? 2. Therefore, equivalent weight of sulfuric acid S2SO4 will be equal to its molecular mass, that is 98, divided by its basicity. Its basicity is 2. Therefore, you get 2 4 8 49. Okay? So, equivalent weight can be calculated in this manner. Now, if it is instead of an acid, if it is a base, then equivalent weight of base or alkali, okay, divided by its molecular mass activity. And if it is a base, then you have to take its acidity. This acidity means the number of OH minus ion it can generate in aqueous solution. So hope this is clear. Now let's move on to then what is a normal solution? A normal solution has to be what? It has to be whenever 1 gram equivalent of that particular substance is dissolved per liter of the solution, then it is known as what? 1 normal solution. So let me read it out. A normal solution of a substance is that solution which contains 1 gram equivalent weight of it per liter of the solution. So whenever you are dissolving 1 gram equivalent of any substance in 1 liter of a solution, then you are going to get 1 normal solution. Now here there are certain terms that you need to know, and like every time it won't be given in say milliliter or liter, the volume may not be given in that. It may be given in other units as well. So whenever say they say 1 normal, then it is understood. But if they say semi normal, then what does it mean? So all these terms you have to learn. Semi means n by 2, semi-normal. So if they are saying semi-normal, it is n by 2. And if they are saying centi-normal, then it has to be normality divided by 100. These terms are very important for numericals. Okay, semi, centi, and you have penti, normal, penti, normal. That means n divided by 5. If it is t or semi, that means it has to be divided by that particular number. Now if they say penta normal, if they say penta normal, penta, that means it has to be multiplied 5 times the normality of the solution. So this difference you need to know it. Penti means divided by 5, ti. If it is ta, then it has to be multiplied by that particular number. Now if it is deca, that means 10n, normality of the solution. So now let's move on to the next way in which concentration can be expressed, that is the molarity of the solution. So we have finished discussing about normality of the solution. Now this semi, centi, this penti, penta, deca will be applied for not only normality, it will be applied for molarity as well. Okay, please don't forget this. Now we are going to discuss about what? We are going to discuss about molarity. Molarity, and it is expressed as capital M. So here the spelling is very important. Molarity, because you have another term molarity as well. So molarity. So what is molarity? Molarity is the number of moles of solid, okay, that can be dissolved per liter of the solution. So what is molarity? Number of this moles of solid, number of moles of solids that can be dissolved, per liter of the solution. So here what you have to know is number of moles, and per liter is very important. So let me write the definition for molarity. Molarity, and it is expressed with small n. So can you see the difference? Molarity. So here again, it is also the number of moles of solids that can be dissolved, and here the difference lies here. Dissolved, okay? Dissolved per 1000 gram of the solution or the solvent. So it is number of moles of the solid that can be dissolved in 1000, and here this is gram, okay? 1000 gram of the solvent. So can you see the difference between molarity and molarity? It has to be dissolved in 1000 gram of the solvent, and here it has to be per liter of the solvent or solution. Hope this difference is clear. I wrote the definition sidewise so that you could make out the difference between molarity and molarity. Now let's come to this calculation part, or the expressions of molarity first. So molarity, capital M. From the definition, you can get the expression is the number of moles. So number of moles of solid dissolved per liter of the solution. So volume of solution, and it has to be in liter. Okay, this is the first expression. Now the second expression that we have is it is related with the weight. Okay, weight of the solid dissolved. So molarity will be equal to weight of solid that is dissolved divided by its molecular weight of solid. That is gram molecular weight of solid into 1000 divided by the volume of the solution in milliliter. So it has to be divided by volume of solution in milliliter. So this is the second expression. And the third expression relates molarity with normality. So molarity will be equal to normality. So before discussing about molarity, we have discussed about normality. So there is a relation. This expression is very important. Okay. So molarity will be equal to normality into equivalent weight. This is EQ means equivalent weight divided by molecular weight. Molecular weight. So these three expressions are for what? Capital M. Don't forget, capital M represents what? Molarity. Now let's discuss about the expressions for molarity now. Now we are going to discuss about molarity. Small m. So I told you the definition. It has to be number of grams of solids that can be dissolved in 1000 gram of the solvent. So the first expression that we have here is what? This one. From the definition itself you can get that. And the second one is it's related with weight of the solid. So weight of solid that is dissolved divided by its weight of the solvent in gram. So weight of solvent and the weight of the solvent has to be in gram. This is very important. Into 1000. Okay. So this is the expression for molarity. Please don't forget it. And now, so what is a molar solution? Molar solution means whenever you have this a solution containing 1 gram molecular weight. Okay, what is 1 gram molecular weight? It is equivalent to 1 mole. So whenever you have a solution, okay, in which you have 1 mole of that particular substance dissolved, and the amount of solvent it has to be what? It has to be 100 gram. So not 100 gram, sorry, it has to be 1000 gram. So whenever 1 mole of any substance is dissolved in 1000 gram of the solvent, then that gives you what? 1 molar solution. Similarly, what is 1 or a molar solution? There again it has to be 1 mole of the substance dissolved in 1 liter of the solution. So these are the definitions of molar solution and molar solution and molar solution. So let's compare about this which one is more concentrated. Okay, 1 molar solution is more concentrated or 1 molar solution is more concentrated. So you know now by now you know the definition of what? Molarity and normality. So here you need to know that a molar solution of a solute in water is more concentrated. So a molar okay solution is more concentrated than a molar solution. This is molar and this is molar. Why? Because see, you know the definition. Molar solution means it is the Because here molar means what? Molar solution means it is the solution containing 1 mole in 1 liter of solution, and molar solution is what? Is the 1 mole in 1000 gram of solvent. So here it has to do with the density. Okay, so at room temperature, at normal temperature, what happens? The density of water is slightly less than 1. At normal temperature, the density of water is slightly less than 1. Yes or no? So if the density is less than 1, that means, see, at room temperature, the density is slightly less than 1. And if that happens, then it is going to affect the volume of this 1000 gram. So this volume will be this 1000 gram. Okay, this solvent, if the density is less, then its volume will be slightly more than 1 liter. So please remember, you have to remember this point. Please listen to it carefully. At room temperature, density of water is slightly less than 1. Therefore, the volume corresponding to 1000 gram of water. So the volume corresponding to 1000 gram of water is slightly greater than 1000 ml. So if this is going to happen, then volume containing this 1 mole, okay, the volume containing 1 mole of solute will be slightly greater than the volume containing 1000 ml. So if the volume is larger and if the same amount of substance is dissolved, then what happens? The volume which is larger is less concentrated. That means little more dilute. Therefore, from this particular explanation, we come to know that a molar solution is more concentrated than a molar solution. Molar solution, it has to do with the density. Okay, and density of water at room temperature is slightly less than 1. Therefore, the volume which contains 1000 gram of this water will be slightly more than that of volume of solvent which contains 1000 ml of the solvent. Hope this is clear. Now, the last expression that we are going to learn is the mole fraction. So, we are going to discuss about mole fraction. So, what is mole fraction? Mole fraction is the ratio. So, fraction itself says that it is what? It is a ratio. So, please listen to the definition. Mole fraction is the ratio of the number of moles of one component to the total number of moles of substance in the solution. So, it is the ratio of the number of moles of a component to the total number of one component to the total number of moles to the total number of moles of substance in the solution, of substances in solution. Okay, and it is expressed with a symbol which is like X Okay. Now, in a solution you have both solute and solvent. Now, the mole fraction of solute as well as solvent. Suppose this is for say solvent, and this is for 2 is for what? Solute. If 2 is for solute, then the total mole fraction will be always equal to 1. Okay, and mole fraction for the solvent can be calculated by, suppose there are 2 components, then n1 by the total number of components, that is n1 by number of moles of one particular substance divided by n1 by n1 plus n2. That is the total number of components. So total number of moles of the substances. This is the total number of moles of the substances, and this part has to do with, it is the ratio of number of moles of a component. It is the number of moles of one particular component divided by the total number of moles of the component in the solution, or the substances in the solution. Similarly, you can calculate x2 again by the same formula, that is, it has to be n2 now divided by n1 plus n2. So these are the expressions which can be used to calculate what? The mole fraction of a particular solution. Now, these are the different terms in which the concentration of solution can be expressed. So, before moving further in detail towards this chapter, you need to know these terms very clearly and the relations. So, we'll be seeing you in next video. Till then, take care. Thank you.